This question says that the complex number W is defined by W equals minus 1 plus iota. Find the modulus and argument of W squared and W cube, showing all your working. Okay, so we will be using De Morgan's theorem here. First, let's find modulus and argument of minus 1 plus iota. Before that, I would be plotting this on an Argand diagram. So minus 1 plus iota is here. Okay, the modulus of this would be, let me write modulus of W would be apply Pythagoras theorem on it, 1 squared plus 1 squared, that's under root 2. And the argument of W will be this angle, which for which we'll first find this angle and subtract it from pi. So tan inverse theta equals tan inverse. This has a magnitude of 1, this has a magnitude of 1. So tan inverse 1 by 1, that gives pi by 4. So pi minus pi by 4 would be 3 pi by 4. Okay, so we have the modulus and the argument of W. Now we will use the De Morgan's theorem and get the modulus and argument of W square and W cube. Okay, so modulus of W square will be square of under root 2, so that's 2, and modulus of W cube will be cube of under root 2, which comes out to be 2 under root 2. If you cube under root 2, you get 2 under root 2. Okay, now we need arguments. So argument of W square will be argument of this times 2, which gives 6 over 4. 6 over 4 pi or 3 over 2 pi. Now the problem with this is that it goes out of the domain. The domain is always pi to negative pi to pi. So this becomes greater than pi. This is 1.5 pi. So we will have to fix it. Right now, this is the angle. It goes beyond pi. What we'll do, we'll write this angle instead with a negative sign. So this would be 2 pi minus 3 by 2 pi, which is half pi, but with a negative sign. So now rewrite this as negative half pi. This is the argument, and this is the modulus. Okay. Now we will find the argument for W cube. This is supposed to be cube. Okay. So for the argument of W cube, we will multiply this with 3 according to the De Morgan's theorem. So that will become 9 pi by 3, sorry, 9 pi by 4. Again, it's way beyond the limit, which is pi. What is 3 pi by 4? Sorry, 9 pi by 4 in degrees. It's 9 into 180 divided by 4. It's 405. So the angle is like this. It takes a full round trip and then it goes like this. Okay, but we are only interested in this. We're going to write this angle only. So we'll do our angle minus 360 degree, but since it went radians, we're going to do 9 pi over 4 minus 2 pi. So it's 1 by 4 pi. So this is the modulus of W cube and this is the argument of W cube. Second part, the points in an Argand diagram representing W and W square are ends of the diameter of circle Find the equation of the circle giving your answer in the form. All right, so we need W and W square on an Argand diagram. Okay. So what would W squared be on an Argand diagram? So in polar form, W square can be written as modulus 2 times cos time argument plus iota sine like this. Now, what is this equals to? Let's find it out. This becomes 0. And sine minus 1 by 2 pi is minus 1. So minus iota, which is just negative 2 iota. And W is already known minus 1 plus iota. Okay, now let's plot this on an Argand diagram and consider that to be diameter of a circle. So minus 1 plus 1 would be somewhere over here. And negative 2 iota, negative 1, negative 2 iota would be somewhere over here. We need to consider this as the diameter. So then the center would be the midpoint. Let's find the midpoint of 0 comma minus 2 and negative 1 comma 1. So 0 plus minus 1 divided by 2 and minus 2 plus 1 divided by 2. That gives us negative half comma negative half. So the center is negative half and negative half. Okay. Then we need the radius. For the radius, I'm going to find this distance and divide it with 2. So the distance formula on negative 1 comma 1 and 0 comma negative 2 is y2 minus y1 plus x2 minus x1. This is under root 10, the diameter. So the radius would be under root 10 over 2. Okay. Now let's write it in this form. So it's going to be modulus z minus, write down the coordinates of center, minus half iota, bracket close, sorry, modulus close is equals to under root 10 over 2. Okay. And you may even write it like this. Okay, no, we need to give our answer like this. So that's our final answer.